Alright, last section of chapter 5, kids, 5.4. Multiple angle identities. So we want to apply the double angle identities, power reducing identities, and half angle identities. So as you can see here, the double angle identities. So you're looking at sine of 2u, cosine of 2u, and tangent of 2u. Now if you notice, cosine of 2u has 3 different things that it could be. Okay? And I'm guessing that we would probably apply those in different situations depending on what the problem was. So, again, to prove the identity, alright, that means we want to take the left side and we want to get it to look like the right side. So sine of 2u. Okay? Now, we're proving that this is true. So, sine of 2u is the same as sine of u plus u. Okay? Now, that is the sine of a sum. So what do we get? We get sine u cosine u, okay, plus cosine u sine u. Okay, now here's the thing. This and this are the same thing, aren't they? Okay, sine u, cosine u, sine u. Opera, uma, opera. Okay, you guys are probably too young for that. Okay, they're the same thing. So, that means there's just 2 of them. Okay, well look. There it is. So all we had to do was break down 2u to u plus u and use our stuff from 5.3 for the sum, or the sine of a sum. Okay, so we proved it. Now our power reducing identities, power reducing. Okay, so what we have here is we want to take the squareds of sine, cosine, and tangent and write them as not having a square. Alright, let's take a look. Prove the identity. Cosine to the 4th theta minus sine to the 4th theta equals cosine of 2 theta. So again, we want to make the left side into the right side. So this is a difference of squares. So we're going to factor. Cosine squared minus sine squared times cosine squared plus sine squared. Okay. Now, cosine squared plus sine squared is 1. Whoops. So essentially I just have this, right? Because this is just 1. Okay. Now, cosine squared. We come back here. So I have 1 plus cosine theta over 2. Well, excuse me. Cosine of 2 theta. Get it right, dummy. Okay. And then minus sine squared. There's sine squared. So 1 minus cosine 2 theta over 2. Okay. So, if I'm subtracting this whole thing, 1 minus 1 is 0. Okay. And then negative times negative is plus a positive, so I wind up with 2 cosine 2 theta over 2. Well, the 2's cancel. What's left? Aha! Look at that. Okay? So again, we're just manipulating things around, trying to get things to look the same so we can get it to the right side. Here's our half angles. Okay? So now instead of, it's u over 2. Alright, so there's our half angle identities. And again, look at tangent. Tangent of u over 2 can be written a lot of different ways. And again, how do you know which one to use? It'll depend on the problem. Okay, so we have to solve. We have to solve algebraically in the interval 0 to 2 pi. So now we have to solve. We're not proving anymore, we're solving. Sine 2x equals cosine x. Okay, how can I rewrite sine 2x? Well, if I come all the way back here, sine 2x is 2 sine x cosine x. Okay, so I just took that and changed it. Okay, move the cosine x over from the right. Okay, factor out a cosine x because they both have it. Both terms have it. Okay, so the cosine of x equals 0, or sine x equals a half. All right. Now, the cosine is 0 when x is 0. Okay. Actually, we don't count 0. We should. No. Whoops. Cosine is 0 at pi over 2 and 3 pi over 2. So there's two of our answers. The sine is a half, okay, when x is pi over 6, so that's 30 degrees, okay, and 5 pi over 6. And again, you can use your reference triangles to figure that out. Okay, so there are 4 answers to this. 4. Alright, here they are. And again, you can use your reference triangles to do this. You don't need a calculator. Okay, now we're going to use our half angle identities. Okay. Now they want us to solve again. Alright, so the first thing we're going to do, so we have sine squared x equals 2. Now, sine squared of x over 2. Okay, sine squared of x over 2. Whoops. Now, by the way, if I squared both sides, if I squared both sides here, that would get rid of that. That's why we're only going to use, actually squaring it would get rid of the square root sign. Don't mind me. It's late, give me a break. Okay, so just to kind of refresh, squaring both sides would give me sine squared of x over 2, and then the square root sign would just go away. So that's how I got this right there. Okay, now the 2's cancel, and I have 1 minus cosine x. Now, to the left side, how can I rewrite sine squared x? The answer might be easier than you think. Think about all the way back in 5.1. Okay? Sine squared plus cosine squared equaled 1. So sine squared is 1 minus cosine squared. Okay? Now, if I minus 1 to both sides, those go away. Now I have negative cosine squared x equals negative cosine x. Okay? Add cosine x over. So I add that over. Okay? factor out a cosine x. Okay, so cosine x equals 0, and cosine x is also 1. Alright, so cosine x is 0. Actually, I don't know why they don't count 0, but pi over 2, 3 pi over 2. Okay, we already know that. Now, where's the cosine x positive 1? Well, it's 0 degrees. Or it's 0. So here's your 3 answers. Okay? And again, we're just assuming when it says solve, we're assuming that our interval is from 0 to 2 pi. So that's why we'll just keep it there. All right? So that's chapter 5. And again, we'll practice, we'll answer questions, we'll get you guys squared away. So that's chapter 5.